In today's lesson, we're going to use what we learned about solving systems of equations and graphing linear inequalities on a plane to use the method of graphing to solve systems of linear inequalities. So a system of linear inequalities is a set of two or more linear inequalities that are graphed on the same coordinate plane. The intersection of their solution regions represents the solution set for the system. If we take a look at our first example here, we follow our same methods of solving linear inequalities. So we'll take a look. It says here, to solve, graph each inequality separately as before, and the solution will be the area which is shaded by both inequalities. It's a good idea to use color here so you can see where that overlaps, but essentially as we move through this, the only place that you're going to want to shade is the overlapping region, otherwise it gets to become quite messy. So let's take first a look at these two inequalities. I'm just going to label them 1 and 2. And you can see y is not isolated in either of them, so let's start by doing that. So for the first one, we've got y minus x subtract 3 is less than or equal to 0. Let's move the x by adding x to both sides. So we've got y subtract 3 is less than or equal to x. And then add 3 to both sides. Y is less than or equal to x plus 3. So that's nice for equation 1. For inequality 1 and inequality 2, we've got 2x plus 3y is greater than negative 6. Subtract 2x both sides. We've got 3y is greater than minus 2x. Subtract 6. Divide everything through by 3. We've got y is greater than negative 2/3 x. Subtract 2. Now that we have these two inequalities, we could put them into y1 and y2 in our graphing calculators. Before I even do that, I can see, using our techniques from before, that this is going to be a solid line. Just a reminder that solid lines are always going to be less than or equal to, greater than or equal to. It's that or equal to that tells us that it's solid, because our shaded region doesn't only include everything up to that line, but the line itself as well. So it's a solid line, and because it's less than, we're going to shade below. At our other inequality, we've got a dashed line here, and we're going to shade above. We're going to use our graphing calculator, put those in, find our x-intercept and our y-intercept for both inequalities, and then we can use that to graph. So let's have a look. Go to y equals, and we've got x plus 3, and for our other one we have negative 2/3 x subtract 2. Zoom 6, and we get our two linear inequalities there. Now, if I use my graphing calculator to shade below for my first inequality, shade above, shade below, and then shade above for my second one, go back and hit trace, you can see the region of overlap. Okay, and that there will be our solution region. Now, as you can see, it's kind of hard to see what's going on once everything's on the graphing calculator, but it's still nice to know that you can check your answers there. You're still doing the work, but you can see where that region is. It's in between those two linear inequalities. So let's go and remove that and find our x and y intercepts. Oh, there's your dash line. And I'm just hitting enter to go through the menu and get that back to where we need it to be. There we go. So trace, that's back there, and it's much easier to navigate and see what's going on. I'm actually sitting right on my y-intercept already, but just as a reminder, second trace value, you're going to put in x is 0 and hit enter. And then if you hit arrow down, so that's on y1, I've got a y-intercept of 3. Put that in here. And then under y2, if I press down, I've got a y-intercept of -2. Okay, get our x-intercepts. Second trace. We're going to go to our zeros. And I'll move to the left, to the right, hit enter. That's at -3. And I believe the other one's at -3 as well. It looks like they're crossing at the exact same point, but I don't want to take that for granted. So let's just do that anyways. Go to 0. Make sure I'm on my other line. So now I'm on y2. Left bound. Right bound. And it is in fact at -3. Okay, let's put all of this onto our grid. So I've got my solid line here. So that's going through 3, and -3, and that's from equation 1. And from equation 2, I've got a dashed line going through -3 and going through -2. So you can see I have arrows at either end of my two lines. Label my two lines here. Inequality 1, inequality 2. Okay. And for the first one here, it says shade below. So I'm going to use red here. And if I were to shade below all of inequality 1, that would look like this. If I were to switch colors now and look at inequality 2, it says shade above. So I'm looking at that and shading above. And just like in our graphing calculator, you can see where that shading overlaps. Essentially, you don't want to be doing all of this shading. All you want to be doing is shading that region of overlap. Okay, and I'll show you what that looks like. So back to where we were, you would just be shading that region of overlap, which would be in here. Okay, and that is what we would label as our solution region. Maybe I'll use a different color there. So what exactly does that mean? That means that if you were to test a point, any value in here, let's say we tested the origin, because it's in the shaded region, it should be a valid point. So it has to hold true for both inequalities, not just one or the other anymore. Whereas before, when we solved for a set of linear equations, the solution set was the point where those two lines met. That was the point of intersection. Now it's that whole region in between or above or below or where those regions overlap. It has to hold true for both. So in this case, it's where below inequality 1 and above inequality 2, and you could see visually where that is. So let's test 0, 0. And now if we're testing it, we have to test it into both inequalities. So for the first one, we would get -3 is less than or equal to 0, which is valid. And in this case, it's going to have to hold valid for both. So trying the other one. 2 times 0 plus 3 times 0 greater than -6. So 0 is greater than -6, which is also valid. So we know we shaded the right area. Now, you don't have to do this test every single time, but it's nice to know that you have that tool in case you wanted to check your solutions. Now, I did mention the point of intersection, and we still need that key point on here. So let's go back to graphing calculator. We go second, trace, 5, which is intersect, enter, enter, enter. And we knew that this was our point of intersection already because that's happened to be where our x-intercept is, but that's not always going to be the case. So here we can see it's at -3 and 0, and it's important that we label that point on our graph. You can even write that in on your notes here. So there's the first example. I'd like you to go ahead and try B, and if you go to our notes later on, you'll see that that'll be filled in for you, so you can check that on your own. And let's take a look at example C. So example C looks a little bit different. We've got x is greater than 1 and y is less than or equal to 5. And if you can remember, if you have x equals a value, that means that value has to cross the x-axis at 1. So that would be a vertical line at 1, and y less than or equal to 5. If that was an equal sign, that would mean that we've got on the y-axis that value 5. So that would be a horizontal line. So unlike our first example here where we have two oblique or diagonal lines, in this one we have a vertical and horizontal line. And really, the rules don't change, just the shading's a little different. We're left and right instead of above and below that vertical line. So let's have a look. So if we call this one 1, this 2, and separate them so we can talk about them a little bit more. So this would be a dashed line because we don't have an or equal there. And this would be shaded because this is my vertical line. This would be shaded to the right. Whereas in my other one, we've got y less than or equal to 5, solid line. Because it's less than, we would shade below. So let's put these two inequalities on our graph. If we start with inequality number 1, it's at going through the x-axis at 1. So there's my x-intercept. And then our other inequality is going through, it's a horizontal line going through the y-axis at 5. There we go. So you can see right here that this would be at 1, 5. But you could also do that on your graphing calculator. Now, as you can see, you could only graph the y inequality, putting in your 5. But if you wanted to know where that vertical line crosses it, or intersects, you could always go to second trace, and under value, you could put in any x value you want. So in our case, we're going to put the x value of 1, because that's what we have here. And you can see that 1 and 5 is that ordered pair, like we anticipated. Okay, so we can do our shading now. Dashed to the right of my vertical line, so that would be here. Dash to the right, I mean shade to the right, and shade below for my horizontal line. So you can see where those two shaded regions overlap. So we don't have to write all of that down. Let's just shade in the overlap. So that would be here. To give us our solution region. Now in your package of notes you have one more example. I'm going to let you try that one on your own, but the solution will be in your notes if you go on our class website and check the notes. Just to note, you've got 3 inequalities here. You've got an oblique one down here. Your y less than 1 is your horizontal line. X greater than or equal to 2 is your vertical line. You've done all of these now. You've got lots of experience. You have all the tools you need in order to graph this inequality and shade that solution region. But give it a go and have a look. Make sure you ask me any questions you need tomorrow in class. But I'm confident that you'll be able to do that. Thanks for joining me today.